Okay, all right. Right about time now. Let's get started. Thank you everybody for joining us for day 2. Hopefully yesterday was fun and you did learn something about Amazon Braket and quantum computing. Today we will talk about QuantumPath and what can you do with QuantumPath. In the next couple of hours we will have presentation as well as workshop and you will get to learn A-Quantum's QuantumPath in great detail. The speaker for today is Pepe. Pepe, I'll go ahead and let you take over.
Okay, hi everybody. My name is Pepe. I presented myself yesterday, but for all of you that don't stay in the day one, I am the CTO of the quantum company, and I have more than 25 years of experience creating and developing enterprise solutions. And I have the opportunity today to be part of the development of a platform that wants to put the quantum technology inside the enterprise technology. So this is my stuff, and I will present our product today to show all the benefits it can put on your hands. So to start the presentation today, we have a lot of people that miss the instructions to prepare the Amazon environment, and we will give the power to Juan in order to spend 5 minutes or something like that to repeat some steps to prepare the Amazon environment in order to have the possibility to immerse into the samples we will do with the QuantumPath platform. Juan, are you okay with that?
I'm more than okay, Pepe. Thank you. Let's go through those steps quickly so you all get your environment up and running. Let me share my screen and I'll take you through everything you need. All right. Let me open a fresh new window. That way we do the steps together. The first thing you need to do is to type the address of the event, dashboard.eventengine.run. And after that, let me see if I can put it here in the chat at the same time. I'm running with one screen today all day, so it's going to be a bit more fun. Bear with me. Oh, thank you, Nihit. I appreciate it. The next thing I'm going to do is to use one of the hashes that we provided yesterday. If you remember, we provided 2 of them. You just have to ask you to use the same one that you used yesterday. That was the first hash. I'm not going to use this one because it was full at capacity. If you used it yesterday, you won't be able to reuse it again today. That was the first one. If you use the second hash, go ahead and use it. The same as yesterday, please. Yeah, otherwise it won't work. Basically, it won't work. So after you enter that hash in the window, you accept the terms and login. Then you need to remember to use the email one-time password. If you're using the same hash that you used yesterday, you will be directly redirected to this screen, the initial team dashboard. You will not need to repeat all the steps of creating a one-time password, wait for the email, and all that. If you are new today and you're joining us today, then you will see this screen next, and you have to click on email one-time password. I'm going to go ahead and do that. That screen is going to take me here to enter my email address. Enter an email address where you can receive an email right now, like immediately, because you would need to check your inbox right after you click on send passcode. So you can see here you have to enter a 9-digit passcode that you should receive in your inbox. I'm going to open my email, check on my inbox to input my code. It should take just a few seconds, but we have seen some cases where it takes up to 15 minutes to get the code. So just be patient. Also, we had a couple of cases yesterday of people having special filters, were not able to receive emails from us. Hopefully it's not the case today. Just refreshing my inbox here to get my code. What we are trying to do here, for those of you who didn't join us yesterday, is basically to configure a fully working AWS environment that you are going to use to connect the platform into QuantumPath, the quantum computing service of Quantum, our dearly partner. Yeah, you can see how my internet connection today, I'm in a different location, so it's blocked for emails, so I'm not going to be able to receive that email. What I would do is to fake it here. Just to show you the steps. It was the preparing format second. And bring my slides. And I will start again. Thank you for your patience. You know, this is just at the beginning until we set up all the environment. After that, we will go faster. Share. So as I was saying, this is the first screen. You enter your event hash, then you click on the OTP option. You should have the email already. You put your email address, and then when you get that email, it comes from this address that you see here. The domain start with US East 1, and is the AWS training domain. Then you just click on sign in, and you should be given access to this screen, the team dashboard with the AWS Console button in the middle of it. Here, you can go to the AWS Console. Now, it's the team dashboard. Can you guys see team dashboard at the moment on my screen? Perfect. Thank you, Kit. So you click in AWS Console. You will see these warning messages. You don't need to worry. One thing that is useful to do is to copy this login link. If you click on that button, you can copy this login link and add it to your bookmarks or save it somewhere where you save all the other information from yesterday. Because by clicking on that, you will be able to access to your environment anytime. No user and password. It will be a clean access to the environment. So I recommend that you copy that. I didn't mention that yesterday. Other than that, you can ignore the rest of the messages that are provided there and click on AWS Console. I'm gonna click my current AWS Console session. It's my corporate Amazon session that is getting in the way. If I click again, you should get access to the actual AWS Management Console. If it's the first time that you access to AWS, you will see a different screen. But what you have to do is to type Braket in the search button at the very top and just click on Amazon Braket. You can add it to your bookmarks as well by clicking on that little star that shows in the screen. I am going to go ahead and click on Amazon Braket again. I'm not monitoring the chat. Are we doing good so far?
Yeah.
Great. Once we are here, if it's the first time that you access to the platform, Amazon Braket, you will see something different to what I'm seeing right now on this devices page. You will see an activation service page. The only thing you need to do in that screen, if you are seeing that right now, is to select the name of the bucket, which is basically the storage unit that you're going to use to store your experiments. I recommend that you leave the default option there, and then just accept the terms and conditions. It's a checkbox at the very bottom of the screen, and accept it and just submit that form. That will take a few seconds. Take you to this screen, the device screen. Let me take a look to the chat. I want to go very slowly here. Okay. I think that you guys are getting answers there, so okay, the hash, perfect. It will help you with that. So the next thing we did after we activated the Braket service was to come here to notebooks. Oops, this is someone else's. Sorry for intruding your privacy. This is basically, I'm the administrator, so I have access to everyone else checking around things. But basically here in the notebooks, you can create a notebook instance. Give your instance a name, any name that you want, test for your name. You can leave the default option. MLT3 medium is fine for the report we're going to do today. And you don't need to modify anything else. You can do it to create notebook instance. And you will see only one line here that says pending. You just need to wait until it's in service. That will take about 5 to 6 minutes. What you can do after that is what you should do after that is to make sure that your IAM credentials are properly created. IAM is the Identity and Access Management product from AWS. The only thing we are doing here to finish setting up our lab environment is to create a user that has administrator privileges. We are going to need that user in order to access to the QuantumPath platform. So as you can see here, all I'm doing is to type IAM in the search box. I also bookmark it and I click on it. Now from here you can create an additional user by clicking on the left-hand side of the screen, the users menu. Apologies again for that. Just click on Add Users. This is only for people who didn't take these steps yesterday and are new with us today. For those of you who already took these steps yesterday, obviously you don't need to do this again. I'm creating my test user. And one very important thing is that I'm going to mark only the programmatic access. I only care about the access key and the secret access key, these two things over here. Because that's how we access to the Quantum platform. So just a username and the programmatic access with an access key. Okay. After that, I just click on Next, Permissions. And in this window, I'm going to pick just Attached Existing Policies directly. Okay, that's the third square this screen. Attached Existing Policies directly. In this screen, you just need to pick the administrator access. That is the second option that is given to you there. And nothing else. You just need to tick that box to keep your user administrator access. and then we click on Next. You can leave this window blank, no need to add any tags. Then we click on Review, and then you click on Create User. Now, this is probably the most important thing that you need to remember for today. Download that file, the download.csv, and make sure that you do not lose those credentials. If today you don't know where to put this access key and secret key, you will not be able to configure your environment unless you left everything configured yesterday. You will have to go through all these steps again. It's not a problem. Just ping me offline using the private chat, or post a message in the public chat as well if you want, whatever you prefer, and I will help you to recover your password if that was the case. It's important that you download this CSV file, save it in your computer, and keep it safe for the rest of the event, because you are going to need that access key and secret key. All right. After that, bear in mind that as soon as I click close here, that's it. I will never be able to recover this secret access key. So be very sure that you have your credentials before you click on this button. Close. And after that, you are ready to go. You can go back to Braket, start working with the platform. Pepe will take you through the next steps in order to configure your environment and get access to QuantumPath with the information I gave you. Again, pick me offline. If you got stuck, I'm here to help you. I don't mind to repeat things a million times if I have to. Again, I'm here to help you. So just let me know. Pepe, the floor is yours, my friend.
Thank you very much, Juan. So I have the control now. Let me 1 minute to share the screen. I will share the screen for full. Are you watching my screen now?
Yes.
Okay, perfect. So let's start. Okay, after this resume of the process to set up the Amazon environment, thank you very much, Juan. Let's start to talk about how QuantumPath integrates with the Amazon Braket infrastructure in order to make us the possibility to create quantum solutions as easy as possible. Okay, we have in front of us 3 hours to talk about that, and I hope that this part will enjoy you and show more about how our product works. Okay, as the summary tells you now, 5 minutes to review that. We will talk about a little tips of the first day in order to put the people on the table the most important things we covered yesterday. And then we will start to talk about the different layers of QuantumPath in order to understand well what the product does and how you can use it to create quantum solutions. Okay, creating solutions, introduction, what is our catalog, how to create some kind of circuits using gates and annealing and something like that. That will be the goal for this afternoon. Okay, so first of all, for the summary of the day one, I want to talk about these 4 points. Okay, the first of all is that we are talking about quantum computing. It's amazing that today we can talk about that. Okay, in the past years, we see how the mobile phones has risen, how the internet is in our life, and today we can talk about the quantum computing. So the most important part for the first day is that Amazon gave us the possibility to provide us from some kind of QPUs or machines that use the quantum mechanics to give us tools to make better solutions, okay, for the enterprise. So at the end, we are talking about something marvelous that is the quantum mechanics. And the quantum mechanics has, at the deepest level, tools that give us the possibility to create more efficient software that can use the power of the nature to solve some kind of problems. Okay, what quantum mechanics gives to us is a discussion that physicists and mathematicians have today, and there are a lot of information and knowledge about that. In our level, we will go up, and we will only work with some kinds of elements that makes this technology really powerful. Okay. First of all, we must understand that we have as tools the superposition and the entanglement. Okay, two concepts that can break your brain. I only need to resume one thing about superposition. We have the possibility to play with atoms and electrons and something like that. Is amazing to talk about that. Okay, but as IT professionals, we are talking about that we have a level circuit the possibility to play with two values at the same time. So the nature gives us the possibility to have some kind of parallelism in terms of nanoparticles, and we can have in the same moment two possible values, the 0 value or the 1 value. Okay, so it's amazing that the machine at circuit level, we are not working with simple electric pulses. We are working with the state of an electron in an sphere. So this let us the possibility to have the superposition effect. Okay, this is a very complex effect to understand, but on the paper we could play with some kind of information that in an exact instant gave us the possibility to know two possible values in the same time. Okay, parallelism in a circuit level. So this gave us the possibility, for example, to create random numbers, because we can say to the nature, hey, please give me a number, and the nature randomly can give to me one of the two possible values if I ask to the nature what value can give to me. Okay, so the superposition is an effect of the quantum mechanics, and in the real life, when you ask to the quantum machine, give me a value, we are making a measure. In this moment, the nature gives us one possible value. But until I don't ask the question to the machine, in this moment, we have these values, the 0 value and the 1 value, in the same time and the same moment. Okay, we need to learn how to use that in our programs, but this is one of the quantum mechanics effects. Okay. The entanglement effect, other effect that is amazing. Two particles in the nanospace and the quantum mechanics says to us that we can have two particles that theoretically are not connected, but in some way they are sharing their states. So if one particle changes its value, the other particle changes value too in the same instant and whatever distance are between these particles. So again, this breaks our brain. But for us, it's a new tool that we need to understand, and we need to know where to put that in order to create some kind of solutions. Okay, today we can play with that. Of course, the entanglement effect is now simulated effect, because there are more to know about that, but we can simulate the entanglement in some way. Okay, the entanglement, what kind of tools gave to us? For example, communications. Two particles in different parts of the world can share their state. So if I change the state in my side, the state will be on the other side instantly, more fast than light. It's amazing. So this is an effect and a consequence about how to use the entanglement. Okay, in our circuits, we'll simulate how to play with that, and we will take consequences about how to use that in more complex situations. Okay, so this is the more important part of the quantum mechanics, and we have the possibility today to use these kind of tools. The qubit is the new piece of information here. At the end, we are playing with the qubit, and the qubit is a mathematical representation of an sphere and the electron giving rounds around it. Okay, because our mind is too limited today, we need to understand that we need to compare this kind of tool to our experience. So at the end, we have taken a standard that use the 0 or the 1 state in this sphere. But in the future, we probably will then play with more stages than more than 0 or more than 1. At the end, the piece of information we are talking about is the qubit, okay? Like the bit, but using the quantum mechanics principles. So this is one of the most important part that we talked yesterday, okay? The second dot is the Amazon AWS services and the Braket part. That is awesome, okay? Today, there are a lot of startups creating some kind of hardware, but each of them has its specific conditions to use the service are really limited in terms of how many people can access the machines. There has a lot of different costs to access to the resources. But Amazon and Braket give us the possibility to concentrate all of these QPUs and all of these providers in some way in their infrastructure, making it simpler the access to these technologies. And of course, make something awesome, that is limit the cost and use you pay for the use of your experiment and no other situations that are more complex in terms of how to consume these resources. Okay, so Amazon, a really big cloud service platform, and this Braket part make us easy the access to these GPUs with a lot of tools that you saw yesterday with Juan and Nihit, of course. The third point that Juan has resumed in the beginning of this session is the Braket environment setup. In QuantumPath, this part is really important because you are preparing your environment in order to access to the QPU. So this is the same for whatever other provider you want to use. As you need to set up, for example, a connection string to a database, you need to know where is your database deployed, your IP, your ports, your credentials. In the case of Amazon, we have the same problem. In order to access to the QPU of the Amazon Braket service, we need to know, understand how to deploy the service, how to connect to the service, and have already documented all the connection strings, the quantum connection strings we need in order to set up our environment. So yesterday we saw what is the conditions that Braket has to prepare the environment. And for us, it's really important to have the credentials, really clear the concept of zone in terms of how Amazon distribute the services in the world, okay? And the S3 bucket, a condition. When the QPU execute some kind of experiment, the results are stored in a bucket, in a file, okay? So these are the pieces of the puzzle that Amazon has in their infrastructure. The last point we saw yesterday is how to set up QuantumPath. We saw again this today with step by step because I need to prepare my environment, and we will use that to align our environments in this part because it's really critical for us to start with this point, okay? Yesterday, we let you the URL. I will put the URL again in the chat or in the screen to register your account in our QuantumPath environment. He talked us about that, okay? I have to say something about that. If you have an account of the QuantumPath platform before the event, please try to forget this account. You probably will have created a free developer account, or you have the enterprise account already set up. Forget it, okay? Don't try to access to the platform today using your account. Of course, there is not a problem about that. But in order to make the demos and not enter in conflicts about how is your configuration, please try to set up again your account in the event, and we will play with the same tools in the same conditions, okay? So I saw many people yesterday trying to register using their previously accounts, and this is not the proper way to start the labs. Of course, if you want to use this account, there's no problem about that, okay? So please use the enrollment feature of the QuantumPath in order to create a new user with your personal information, and you will receive all the instructions to access to the environment, okay? So I have to say some more and finish this introduction and this resume of the first day. I have to say that Juan talked yesterday that the quantum technology is not enough mature today in order to put into the industry, okay? That is real. The quantum machines and the gates quantum machines specifically have a lot of problems to solve before to use in the industry, okay? They have the lag problem of the errors and the coherence and some problems around that. That makes this technology not enough mature to be used in the enterprise. But that not means that we must use this technology today in order to understand how this works and how can we gain some kind of advantage in our solutions in the company, okay? Annealing technology today, we can say that is mature enough to be used in a specific kind of environment, because this technology of the wave technology, the annealing technology, can be used in production environments in a controlled situations, okay? We must remember that the case technology is more general, is for create algorithm, very complex algorithm, are programmatical machines, so we know what this implies in our life. But the annealing technology is like an electrodomestic, okay? The annealing technology makes the possibility to create specific use cases around the optimizations, and we will see later in a demo how this technology works. But today, this technology is mature enough to be used in some kind in production environments, okay? I have to say something more. Yesterday, we talked about that we have the possibility to use QPUs that are real machines that use the quantum mechanics in real machines with all the problems they have. But we talked yesterday too about the simulators, okay? Simulators are tools that even perhaps they don't execute an experiment in a real machine, they simulate how this works. So we can use classical machines or classical supercomputers in order to simulate some kind of experiments. In the same time, I have to say that in our company, in Quantum, we have created some experiments that demonstrate that we can create quantum versions of classical programs, and we have advantage doing that. And this is called quantum-inspired technology, okay? We don't use quantum computers, but use the quantum principles to create new solutions. And at the end, the surprise is that this takes less development time and less execution time than the classical equivalents. So it's amazing that you experiment that, okay? To finish the resume, I need to put a tip on that prior to talk more about QuantumPath. QuantumPath is a multi-tenant platform, okay? So this implies that QuantumPath is organized into organizations. You can register in the platform using two ways, the free developer account or the enterprise or professional ones, okay? In these cases, you probably will have an account in the platform. So please don't make a mistake. If you access to the platform with your previous account, you will play with your rules. But if you want to play with the rules of the event, please repeat the enrollment process using a new account, and we will play in the same too, okay? So let's start with the QuantumPath Solutions. That is an amazing concept, okay? In QuantumPath, we have to have in our mind that we are creating a product that tries to put up the level in which we want to work with the quantum technology, okay? The first of all we have to understand is it's a really new technology, and all the people are testing this technology using different pieces in a very basic level. For example, you are using the notebooks to create some kind of proof of concept. But at the end, this technology will be used in the real life. So for us, this means that from an engineer perspective, we need to put this technology inside the box that it corresponds. So what is for us the QuantumPath solution? The solution is the classical defined solution in an enterprise. The solution is the IT program that solves some kind of features that a user requests to us, okay? We create software, we create programs, and these programs respond or answer, to some kinds of features that the users need to make it work, okay? So the classical software solution responds to a construction of a product that covers business needs. With the appearance of the quantum technology, we could see in the presentation, is necessary that we rebuild our brain in order to how to put the quantum technology inside this kind of software solutions and take advantage for that, okay? At the end, we are talking about a quantum solution, a software solution that responds to the construction of a product that covers the business needs, but using the advantage of the quantum computing. In QuantumPath, we have built a complete ecosystem, a really complex platform in which we want to make easier the integration of the quantum technology inside the classical design of software in terms of the industrial or business needs. Well, what QuantumPath is, you can see this cloud. Inside this cloud, we have a lot of technology pre-built in our company that makes possible to use the best practices in terms of software engineering to adapt easily the quantum technology. So we are talking about that we have an ecosystem of software tools that use the best tools of the computer today, okay, that reflects the use of project management tools, the control of the life cycle of a solution, the concept of quantum assets that for us are the most important part of the product is the pieces that are used to build the software, okay? So for us, these are the quantum assets. And we have a lot of stuff to control how we create that, okay? The Enterprise BPM Core is a complete software solution that runs on the Amazon infrastructure that gave us the possibility to have a web UI environment to control the process of the project management, for example, and a lot of backend infrastructure that uses the best of the Amazon layers to create machines to respond to the load of the system in one moment, okay? Integration and extensibility. We will talk about that with our qSOA API REST. When you create components, you need to integrate these components into the enterprise. So all the stuff you will create with QuantumPath at the end will have a use case that you can enable in your classical software. We will see how to do that. And of course, notifications, error control, versions, all around the creation of a software tools, okay, will be integrated in our platform. Our platform can run in on-premise versions. If you go to the enterprise level, for example, you can install all the QuantumPath platform in your machines. But at the end, we offer the service in the AWS cloud services, giving all the power we have inside this platform to make this real. Okay, so this is the schema we have in order to understand what QuantumPath is. From the creation of the quantum algorithm to its development, testing, implementation, all the roadmap we have to create quality software is implemented in the pipelines of the QuantumPath technology. Okay. Well, we will see how the platform works, okay? If I talk too much and there are a lot of questions to be answered, my colleagues will interrupt me and we will talk about that. So let me 1 minute more to talk about the QuantumPath introduction, and we will start to use the platform to see how all I'm talking about is real and you can play with that, okay? Really important. QuantumPath is an agnostic platform that allows you the definition of all the components that uses the quantum mechanics to create complete solutions, okay? What that means, agnostic platform, because there are a lot of people talking about that. This concept of agnostics could be not clear if you don't set the rules and put on the table. For us, agnostics means that we have a platform that use a high-level language that we call meta-language, in which we have the representation of all the generic elements that are important for the quantum mechanics. And all the details that you have in the underground, for example, all the detail levels at SDK in case of Amazon or other providers, are totally hide to you. For you, the most important part is that you put the focus in your problem, and you must put the focus in the problem using the tools that quantum mechanics gives to you. But you don't have in your mind all the details that will be different between providers, okay? Or for example, you probably may suffer the versions of the SDK. The provider can change the version of the SDK, and you probably need to change your code in order to adapt to these changes. So keep out of your mind and keep in your mind that QuantumPath tries to make the effort to put the level in a high-level tool to make agnostic the platform. We will see later, we have the possibility to use a complete set of gates that can be run in whatever machine you need. Even if this machine doesn't support directly this gate, we are capable of run some kind of transformations and optimizations that make possible the use of our gate in whatever gate machine you have in your hands, okay? The same with the annealing part. We have to separate the technology in two worlds, the gate circuits world and the annealing world. In this part, we have to say that we have a really agnostic QO formulation that use the most clean part of the physicians that talks about the Hamiltonians and something like that. We have the representation of a Hamiltonian that use the best practices of the physicist part. So we have a high level definition of the QO formulation that gives you the possibility to run this QO formulation in whatever QPU that support the annealing technology. And in a really near future, we can run this experiment in whatever gate machine you can in our hands, okay? So how this give us some kind of advantage? Okay, first of all, at level company, you need to identify a problem that could be solved using the quantum power. Not every problem could be solved with the quantum technology today. So the first step we have in our mind is that we need to identify the problem and know if this problem using the quantum technology is easy to solve and is possible to solve, okay? The second step you must have in our mind before use the platform is determine what kind of technology you need to use to solve the problem. This put us a condition when we create the solutions, and it's important to make it clear from the beginning, okay? We need to choose what kind of technology we must use to solve a problem. We need to choose between gates, and we need to choose between annealing. This will limit us when we create the solution, because we will select some kind of providers in base of the technology we need to use, okay? And we will define later the gates or the qubit matrix with all the stuff we have around that, okay? So let me minute to see the messages in the presentation. So let me have 1 minute, please. Well, in a few minutes, because I know that a lot of people want to just access to the QuantumPath. So let me have a few minutes and I will share with you how to connect to the platform, okay? Well, in terms of how we use QuantumPath in the company, we have our quality plan. So we thought our product in order to be easily put inside the quality process of the design of the software in a company, okay? When you want to use QuantumPath, you need to follow our working flow. In this case, you probably will have a complex in the company or in your team or your research environment, okay? And you will have in your company probably different knowledge, different people, different roles that must be worked together in order to solve some kind of problem that involves the quantum technology. My boss told this kind of teams polymaths, okay? So then the next process is when we have clear the requirements, we need to solve some kind of problems using mathematical formulation. For example, when you create the circuits, you need to select some kind of gates to rotate the electron and obtain an effect that solves the problem. It's the same with annealing technology. We need to define the Hamiltonian that in some way will benefit some properties of the problem and will deny some kind of effects that we don't want to obtain in the problem. And we will create the QO matrix around that, okay? With all of this information, then the team access to the QuantumPath, use the QAsset compositor tools, and create all the assets. The platform will give you all the tools to compile, transpile, and prepare all the environment to test your experiments and decide when your experiments must to be to production and will be used for the classical systems, okay? So at the end, we put our problems in production and we'll use the QPUs to solve the problems that the classical systems will use through our qSOA API. And this will be run until we finish some kind of problem. Okay? There is a problem with the audio. Are you okay with that? Okay. Well, I see that there are people that not have it to the QuantumPath, and in a few minutes we will share the URL and we will repeat the process to access to the platform in order to start with the experiment. To finish the introduction, because we have talked about the platform too much and we need to show that as soon as possible, okay? This is important, and this is important to have in the mind before to access the platform, okay? In QuantumPath, we use 4 levels of abstractions in the platform, okay? We use the graphical way when we want to adopt the technology fast, and we need visual tools in order to compose our problems. So in QuantumPath, we have the QAsset compositors to create circuits or create annealing solutions, okay? But behind that, we have our pseudocode. Al final, at the end, we are creating pseudocode, a meta language that easily implements the algorithm using some kind of string representations. Of course, this pseudocode will create all the products that are launched to the QPU. We have the direct code level. This is a really freaky part, because if someone has a lot of experience codifying in Python or C# or whatever other language and know the SDK of some provider really good, they can choose to use this way. This is not our preferred way, because you are in the lowest level of the platform and you will have a lot of problems too, but it's possible to create direct code inside the platform. And what is the 4th level I talk about? I will see later in the presentation. Our qSOA API is a REST API in which you create the classical part using a classical language. You can use C# or Python or whatever other language to interact with the QuantumPath system and create in a different ways assets, execute them, get the results, and something like that. So to finish, this is the pipeline we will follow in the rest of the demos, okay? First of all, we analyze the problem. The second way is to create the solutions, selecting the technologies we need to use to solve a problem. We need to choose a solution for gate circuits, and we will create solutions for annealing circuits. Then we will set up the QPUs in order to provide the connection strings we need, and we will keep our solution ready to be used in a complete development of a quantum solution. The 4th step talks about the creation of the assets itself. Once we have the solution ready, we will start to create all the pieces of the puzzle that we will combine in order to create a complete solution, okay? And to finish our experiments, we will be ready to execute the experiments, try them, get the results, analyze the results, and when we are enough prepared to know that this experiment is ready to put on production, we will decide to put on production and enable them to be used for the classical code. So once we have talked about that, let me stop a few minutes to show if we have some kind of questions about that. Okay, Mario, there are a question around all the...
Just how to enter in QPath.
Oh, all the people who want to enter into the QuantumPath. Oh my God. Okay. First of all, let me remember one step. Yesterday, he told you about how to engage the platform. Oh, let me share that these URL are not good. So let me a minute. I will enter in the system and I will give to you the proper URL, because this doesn't work. Okay, only 1 minute. Only 1 minute to do that. I go to the enrollment system and I will put the URL properly. Okay, So let me 1 minute. So that is, let me share into the chat this URL. That there will be a problem with some character in the copy and paste of the link. Okay. If you use this URL, you probably will see this screen. Can you see this screen? For all those of you that yesterday couldn't access here, please use this screen to register yourself. In this case, the most important part for those of you that are already users of QuantumPath is to use a new username here. In order to not conflict with your previously accounts, I recommend you to use some kind of suffix into the name. For example, put AWS AQ as username, okay? And in the email, you can use your mail even if you use it in previously registrations, okay? So you can use here, for example, my email, okay? Okay, password, you need to follow some kind of rules we have in the system, not mix some kind of characters and something like that. First name, last name, and you will receive this reason in your email when the system complete the enrollment, okay? So for those of you that you couldn't access yesterday, you can access now to this link, fill in the data as we talk about, and you probably go to the login page, okay? Can I follow with the presentation? Exists some problem in this part. For all those of you that are enterprise users of QuantumPath, this is a new feature we have that is called the team engage and management. You can create your own events, can invite to the people, and then the people using the enrollment page or the QR code can access to the platform and auto-invite themselves, okay? So if this is okay, the next step is to log in into the platform. So when you click on the complete enrollment, you will receive your email with a welcome into the platform, and you will be redirected to this screen. If you go to the main page, you click on the login system, okay? And here we can use the username we have specified in the form, okay? Then you can put your password here. Someone can put the password really fast. Sure, you have the possibility to recover your password if you use this link too. And I will go into the platform, okay? I am accessing to the platform using the same privileges like you. In this case, we have created a role with the manager privilege. In this case, the manager can access to all the system assets catalogs, and we have limited control from the system. When we create the manager role, we are talking about that you are a chief project. You can create solutions, you can prepare the environment, and then you can invite, for example, developers in order to create the assets, or do the job yourself. Of course, at the end, the chief project has a lot of responsibilities in the project, okay? So in this case, let me navigate really fast to the options of the product, and let me set up again the solution as you did yesterday to resume again the process and to prepare myself my own connections, okay? Well, this is the dashboard. QuantumPath is the main dashboard in which you can see all the experiments you are doing, some telemetry and something like that, and you have different access to the main set of assets you can have in the platform. Okay, I'm seeing 130 solutions, but I couldn't see them because every of you has the role to be the owner of your own solutions. Because I'm not an administrator, I can access your information. This is important when you want to run your experiments or your developments into a Teams. It's perfectly understandable, okay? So let me review again. I will go to the dashboard, and using this link or going to the tools menu, I can access to the Quantum Solution Catalog. This is the most important part when we are preparing our environment, okay? So in this case, let me repeat the steps you did yesterday to prepare my environment. we will select some machines for some kind of problems or gate circuits and other solution to create some QPUs connections to make annealing experiments. So for that, I will create two solutions. I go to Solutions link, I click on the button Create Solution, and in this simple metadata window, I will go to put, for example, my solution, okay? So, it's my solution for gate circuits, okay? Well, once you have put some kind of metadata, it's a really complex form, I understand, I will click on Save. In this case, we have set up our box, and in this box, we will select what kind of platforms we need to use to execute our experiments. The best part of that is that we put in our box as many QPUs as we need to research our experiments, and we can choose them free without no problems. Of course, it's important to do this in the first step of the creation of a solution, but we can change in every moment. We can enable, disable, incorporate new machines as simple as click on a button. So let me click on the platform button, and you will see we have different providers here. And I will select, of course, our Amazon Braket drivers. In this part, we can see, mixed all the environments that we can have inside the Amazon Braket system. In this case, we mix our in-house simulators that you can see that has the name the Power Local X Axolotl simulation. In this case, this simulator can run in our QuantumPath platform. It's an in-house simulator. This will not be executed in the Amazon part, so it will not cost you any. The rest of machines, for example, there are, for example, Manager State Vector Simulator, the ESV1, or we have the D-Wave Advantage System 4.1. We can select here whatever technology we need to use. But keep in mind one important thing. In this version, we only can select one kind of technology for each solution. In QuantumPath 2 or 3 or 4, we will mix all together. But today, it's important to prepare that, okay? To finish the configuration of our environment, let me talk about your profile, okay? In QuantumPath, we have a lot of features and a lot of buttons to prepare all the assets. And we need to use some kind of buttons to create some kind of artifacts. In order to make it simpler and only put the focus in the problem that we talk about in the event, please follow me in some configuration of your profile. If you go to the menu and go to System and select Manage User Profile, or you go to the icon of your profile, you can access to this screen. In this screen, we can the possibility to customize the behavior of QuantumPath for our user. In this case, let me click on Save All Behavior. When we click on that, when we create a circuit, and you click on Save Circuit, you will see later what I'm talking about. The system will save automatically the circuit and the metadata around the circuit. So in one click, you have all your assets saved. For other people, it's not useful always. I can understand that. But in order to make it simpler, please select the Save All behavior in your profile. In the same way, I will click on the Auto-Compile button and the Auto-Transpile button. If we select this behavior, when you save your assets, the system will compile automatically your assets in the context of the behavior of the solution. Keep in mind that we are talking about a developer environment. And when you create solutions, you need to create the code, and in some point, you save your code and compile it. And you are sure that your code are compiled perfect and you have the keys in order to execute it. In QuantumPath, we have the same problem, okay? In order to simplify the process of save, compile, you can select these behaviors, okay? When you save your elements, the system will be enabled automatically these kind of events in the platform. In the same way, I don't recommend you do that, but it's important. Yesterday, Juan told you that when you run an experiment in the backend, you probably will have to wait some minutes or even hours due to the queue that the quantum machine has, because there are not so much machines in the world. So you are fighting to access your time slice in the QPU. If you need to launch some experiment and you want to go until the results come to you, you can enable the notifications. And the platform, when the experiment finishes, will send you an email notification taking to you if the process will be okay or not. If you want to click here and receive the notifications, please enable that. If you don't want to do that, please leave it as you are seeing now. Okay. Once I have selected these behaviors, let me click on Save Profile, and we are ready to go again the rest of the event and create our experiments. Is already clear until that point? I go too fast. You want to be more slow? Everything is okay? There's no question until now? Where do we get the token for the Amazon Quantum Services? Okay. How do you go back from the profile to editor? Okay. At the end, you need to play with the system navigation options you have in the problem. Okay. If you are in this screen and want to go again back, you can click on the menu or click on the back button or something like that. Okay. I will click on the dashboard and we will let the screen here before to explain the rest of the event. Okay.
Pepe, perhaps it's better to wait for some minutes in order that all the people can connect without problems.
Okay, so I need to wait.
Any other problems?
Okay. Okay. Someone told yesterday a question that I have in my mind here. What if I put back the credentials in the environment? Okay, QuantumPath in this moment doesn't validate the credentials you are putting in the solution configuration. Why? Because it probably implies that you need to access to the platform, run some kind of a small experiment to configure the platform, and this will incur on costs. So for today, we don't validate the information until you run your first experiment. So if you fill back the information in the credentials window, you will probably have an error when we execute the experiment. We could see later if we have enough time. Okay. Well, let me continue with the event. So let me put the PowerPoint again to work. That is.
Can you guys hear me?
Sorry?
Oh, you can hear me now. Okay, thank you. Sorry, go ahead. Okay.
Yeah, thank you very much. Well, let me go fast to this part and I will talk fast about that and we will start our first experiment. Okay. Well, QuantumPath has a life cycle and asset catalog. We will see now. I talk too much and we need to see the platform, okay? But it is important to keep in your mind some kind of parts of the flow in order to understand well how we can do the experiments. Okay, the QuantumPath life cycle at the end is the flow you must to follow to create a solution. First of all, we have to create a solution. The next step is create the assets. In the assets part, we can create two kinds of objects, the circuits and the flows. The circuits are the pieces that define the algorithm, and the flow is the part that you create your main program. If you have a lot of circuits or you want to run your circuits inside some kind of context, the flow editor is the main program that correlates how the circuits must work and all the properties they must accomplish in order to be run in the QPU. When you create the circuits, you are storing your assets in the catalog. When you create the flows, you correlate your assets in one main program. And at the end, with this information, the flow is your main program. It's the most important part. Then, when you have finished the flow, you can go to the runtime dashboard pane and execute it and get the results. You could see some kind of screens here. Of course, from each of these flow elements, you can navigate through them and search and go and navigate through your elements. Okay, so these are the steps that you need to follow in order to create a solution. When you create assets in the platform, QuantumPath tries to store your information in a metadata database. So for each element you can create in the platform, you have some metadata that will let you tag your information. And with all of the information, we can create a repository with all the elements that compose a solution. So for that, we have all the CRUD use cases in order to manage the information you are creating. You have metadata edition, in which you can put all the tags you need to classify your information. We will have for every piece, for every asset, a visual designer directly connected with your asset. And of course, you will have a lot of actions around the assets. For example, the save action, the compile action, and something like that we will see in our experiment. When we create our assets using the visual environment, we have all the tools under a web UI environment, and we will make this easy because you can drag and drop all the elements you need, and you don't need to codify anything at this moment. So it's as easy to drag and drop your boxes, prepare your environment, and execute that. All the products in the behind of this environment will prepare everything to be launched into the QPU. You will play, with the namespaces for create taxonomies. This is really important. When you use a language like C# or Java, you need to classify your classes into a namespace taxonomy. If there are a lot of people working with assets, the definition of this namespace could avoid conflicts in terms of name when you are creating a lot of stuff in a solution. Okay, multiple saves. You have different saves to drag and drop in their box, and we are playing always with high level, and of course tries to have zero code when you define your environment. When we use the different quantum compositors in the visual environment, we will have two kinds of tools. The first of these tools is the Quantum Asset Compositor for gates. We have a tremendous editor that will be changed in future versions for some architectural reasons, but in this case, we have a gate designer that uses unlimited qubit scale. Even we have limited problems for more than 24 qubits. This is a web environment limitation that we will solve in the next version, okay? We have a full agnostic gate set. These gates that you can see in the screen, and we will see later, are a complete gate set that is independent for every QPU you have in the system, okay? And we will have some kind of virtual gates that let you create some kind of flow conditions inside the circuit definition. For example, a repeat block of elements could be selected using our Braket gates. So we have a lot of features in this part that gives you the possibility to don't codify anything, because we are covering all the use cases in terms of circuit design. Okay, we have helper actions with you. When you drag and drop the pieces, the UI will help you to set up the environment. We can have operations over the circuit, and agnostic multi-control gates. This is important because the multi-control gates are not supported for every machine today. The multi-control gives the possibility to enable some control qubits to control a gate. Today, there are machines that you only can set up, for example, Toffoli gate or CNOT gate, only support this condition. But in our platform, we support the multi-control gate in an agnostic way, so it's amazing. And of course, the rotation Pauli gates, if you want to create your own gates to create some complex problems. So at this point, we are ready to our first demo. I know that the people want to see that as soon as possible. We will make some experiments with the gates editor, and we will make a rest of 5 minutes or something like that, because, oh my God, the time is running so fast. So are you ready to start this part of the demo? Everything has clear the solution environment prepared. Everything is ready to start an experiment. Okay, let's go. So to start to create the solution, remember that you have here 2 solutions. Now, following the flow, we need to create a circuit. So I will go to the next step. I am positioning on the working on circuits. If you don't follow this way, you can go to the menu and go to the Quantum Circuit Catalog too. It's the same use case, okay? When I am here in the Quantum Circuits Catalog, I will click on Create Circuit. And appears the metadata of the circuit creation. In this case, I will put here prepare. And I can select a namespace because in our system, we doesn't define anything before. I have the circuit namespace clear. So I can choose this moment to create my namespace, because all of those people that are connected to this environment are sharing the space. If every one of us put the developer name and we don't specify a namespace, we will probably have a conflict in the name of the class. To avoid that, let me select as namespace my name. Okay? I suppose that anything of the people that are connected has my name. So for me, this is not a conflict. But be careful. If you select the namespace and the name, and other people has the same combination, you will probably have a conflict when you save that. So it's important to define a right namespace and a right politic to create the full name of an object, as you have the same problem in some procedural languages. In this case, I will select my Solve Demo Gates solution. I want to create a quantum circuit that uses gates to solve a problem. So I need to select a solution that is prepared for that. Okay, quantum type. I need to create quantum gates. So I need to select this kind of object that I want to create. In the description, pair demo. And here comes the magic. I can try to define my circuit with the visual intermediate language, or I can click on the edit circuit to go to our quantum compositor for quantum circuit editor. And you can see visually the circuit designer. That is amazing. Until now, we have not codified anything using whatever language, okay? So to create the bell pair, the one on the simulators or the one on the QPUs, well, I have created a solution in which I mix simulators and quantum and QPUs, real QPUs. So it's the same. Well, in this case, to create the bell pair, let me drag and drop the Hadamard gate, and then I will click on the control gate, and then I will drag and drop the Pauli X gate. If I do that, I have created the bell pair environment, the bell pair circuit. In this case, what we are doing, keep in your mind that we are learning how the quantum mechanics works, and we need to have some kind of intuition. The most simple experiment we can do is to test the superposition and the entanglement. These are the two parts of the circuit. if I put a Hadamard here, this means that whatever the value I have here, I put the quantum machine into superposition state, and the next step, I don't know what is the value I have. It could be 0, it could be 1 or 2 at the same time. If I create this circuit composition, I am talking to the machine that whatever the state have here, I need to connect these two qubits together. If this qubit have the value 1, the control enables the node on the next qubit, and here we will have 1. If this value is 0, the control not enable, the value that enters is 0, and we have 0, 0, or 1, 1. This is the effect of simulation, the superposition, and the entanglement. This has no practice value in the real world, but to test a machine is enough for us. Okay? Well, if we put that and we don't put any gate in the right, we probably will execute that and we have 0 value of result. This is because we need to measure the value if we want to know what is the value that the quantum machine wants to give to me. So it's important to drag and drop the measurement gate when we want to get results. If you don't measure, you probably will not get ever results of the quantum machine. If we want to compare that the qubit 0 and the qubit 1 have the same value, we need to measure the two qubits. So let me drag and drop these two measure gates in these two parts of the circuits. Is this okay? Well, later we will do another experiment, more simple but useful for us. Let here the circuit and let me click on Save Changes, because I don't enable the profile in this case. So when I click Save, I go to the previously window. I can see here the visual intermediate representation, and I will click on Save. But before click on Save, to avoid some kind of time later, let me click in the auto-generate flow. Okay, if you usually use QuantumPath to create a simple circuit and your aim is to prove this circuit, if you click on auto-generate flow, QuantumPath will create a flow for you with all the stuff that you need to run your experiment as soon as possible. So let me click on auto-generate flow and click on Save. Once I have that, because I click on the automatizations of the system, I click on Save, and you have seen different messages appear in the screen. These messages has told me that I have saved the circuit, and the circuit has been compiled for me. If you want to see the results that the compilations is okay, you can click in this button in order to show that. Let me click on the compilation details. I am see here our intermediate language. At the end, all the purpose of QuantumPath is to have this string. With this string, we have the agnostic possibility to translate this string into different QPUs on demand. Okay? You can
you make your screen a bit bigger, Pepe.
Sorry, Mario, tell me.
You make your screen a bit bigger.
A bit bigger, okay. Excuse me.
That's great, thank you.
Okay. Well, again, our circuit with the visual intermediate language, and in compilation details, the intermediate language. Okay? This is information that will be enough today, but in future events, this will be really important. I will talk about that. Okay? Well, once I have finished the definition of the circuit, I go back to the list. I have here the description of our experiment, and I can go to the next step flow, because I click on the auto create artifact. The system has created for me a bell pair flow with an aleatory unique identifier. If I click on the edit button into the grid, I can see that I has all this filling for me by the system, and a visual representation of the flow. And if I want to see the flow, I only need to click on the Edit Circuit Flow. In this case, we are seeing the quantum asset compositor for flows. In this case, the system recover automatically all the circuits we have created inside a solution, and we only need to drag and drop this part on the screen and compose something like that. We start, we begin from 0, we want to execute the circuit 100 times and go to end. Of course, if you have more circuits, you can drag the circuit into the flow, connect the dots, and click on Save, okay? If you want to make this name simpler, you can change in whatever moment. I will click on Bell per Flow and click on Save, okay? When I click on Save, what occurs? The system will compile, will transpile, and now we have everything ready to execute my experiment. If you don't have enabled the profile automatizations, you need to save, you need to compile, and when everything is okay, you need to transpile. Why we have put these use cases separate? Because always you won't need to execute this kind of actions because there are a lot of people working with you. So we prefer to put transparently these events, and you can enable these events as you want, okay? But because I have my automatizations enabled, I can click on Save, and the system will save, will compile, and will transpile my flow. At the end, the most important part when you finish the flow is the transpile action. The transpile action prepares everything in the backend to run your experiment in as whatever QPUs you have selected in your solution. So let me go back to the list, and once we have here the runtime dashboard. If I click on the runtime dashboard, we go to this pane, and in this pane we will see all the machines that we have selected before in the solution creation. In this case, you could see I have the local simulator, the Rigetti Aspen1, IonQ, and TN1. From that, I can select one or two or every GPU I want to run my experiment. So for me, it's really easy to execute my experiment in as many machines I need in order to compare results, see efficiency of the machines, response time, and all the stuff around the telemetry. So let me click in every of one.
Pepe, sorry. Could you please summary a little how to create a circuit, compile, create the flow, to summarize for some people, please?
Okay. Let me repeat the problem, okay? I start in the solution. We have solution in which we have defined the QPUs that can able to run some kind of gates experiments, okay? Then I go to the circuit step. In this circuit step, I have create a circuit. If you are creating or are editing, the screen is really the same, okay? So I go to the edit part. I have filled in the name of the experiment. I have created a namespace with my name. The solution I have selected is the gates one. The technology that I will be use is the quantum gates technology, the description, and the circuit body. In this case, you probably don't have nothing here, or I will paste here. If I click on edit circuit, I can drag and drop the gates, creating our well-paired circuit. With that, any problem?
No, I think you can continue.
Someone wanted to know how to create the single gate. How did you make the link between the two qubits in the editor?
Okay. So we have defined the circuit. We have saved. I have automatically saved and compiled my circuit. If you don't have enabled this option, when you save the circuit, please click on compile. And if you see that everything has been okay, we are ready to continue to the next step. If there are no problem with that, I will go back to list and I will go to flows. In this case, we have the flow defined with the circuit. Okay, if you don't have that because you don't select the flow, we can create a flow. And I will click, for example, verb here, O2, namespace, I name, solution, description, and I will click flow body and click on edit circuit. Let me show you how you create the flow without our wizard, okay? I will drag the start shape. I will drag the initial of the 4. I will drag the circuit that the system has loaded for me. I will drag the 1,000 iterations, but I will click on it to select 1,000. I will click and drag the end shape, and then I will connect the shapes, okay? If you have that, you can again save the changes, and we have the flow ready to be run, okay? Our wizard make that easy because it's the most usual way to create the flow. Any doubt about that? Everything is okay? Okay. So I go back to the list. I don't save this, so for me it's not a problem. If someone has created a lot of flows and want to delete them, only click on the delete button and that's all. So then we follow to the experimentation and run the experiment, okay? Well, how to get the arrow in the flow? Okay, let me see again. If I click on the edit circuit flow, if you drag a shape here, you only need to connect the dots between shapes, okay? It's as simple as select the dot and drag to the shape you want to connect to, okay? Well, let me go again back to the quantum circuit flow catalog, and when we have that, let me run our experiment in the QPUs or the simulator or whatever you want. In this case, I will click on the button of the runtime dashboard, okay? Once we have clicked, we are in the dashboard of the executions of QuantumPath. And here again, we have the QPUs that we set up in our solution step, okay? And I here can click 1 or 2 or all the QPUs that I have set up. I can do that. It's as easy as check the box. And when I am ready, I will click on Run Flow. In this moment, we are running our experiments in the backend of QuantumPath. And the VPM are launching now the products that are calling the QPUs wherever you have the QPUs. So you could see that the first to be end are the simulator ones. The Aspen M1 has finished now, and probably the IonQ will have a most heavy queue in order to give me the results. But we have 3 results received now. It's amazing. So once we have the results, we can click on the histogram button and see what histogram has been received from the different QPUs. In QuantumPath, we normalize, we homologate the results following one standard. So we could see the same results for every machine. And all of these results will be stored in our database. You can get these results through API or through the environment, whatever you want, okay? Let me click, for example, on the local simulator that has been run into QuantumPath. You could see that local simulator is true in this situation. So in this case, this experiment has run inside QuantumPath. If I click here, we could see that the bell pair has 49 for 00 and 51 for 11. Again, as Juan talks about yesterday, if someone gets the 50-50, wow, amazing. If not, this is the most common results you have to hear, okay? Well, Important. In this case, the simulator gives us coherent results. We have the 0, 0 and the 1, 1, and everything is okay. But what about a real GPU? For example, the ASPEN M1. If I click here in the histogram, we could see what we have. For example, the 1, 1 and the 0, 0, the most part of the times. But see this part. We have a 0, 1 value and a 1, 0 value. These are noise. These are errors in the quantum machines. So this is all that Juan talks about yesterday, that the providers need to solve problems in the real GPUs. There are a lot of problems around the mechanical that use the quantum computers, and these are artifacts that are caused through the noise of the machines. So this is important to know the fidelity of some kind of machine. For example, what kind of noise can we have in the TN1? If I select the TN1, because it's a simulator, we don't have noise. We have to wait to the ion Q experiment in order to see what kind of fidelity this machine has. Okay, so that is. And we can run this experiment as many times as we want. For example, if I don't use ion Q, because we could see that ion Q has a heavy Q, we can use, for example, again, the TN1 and the Rigetti ASPEN 1, and we can click again in the run flow as many times as we want in order to see the results. Okay, because we are working and we are a lot of people, probably the backend are running a lot of experiments now, and we have two machines in the backend with limited 200 of processes now. So you are inside the local queue of QPath. If you run your experiment and you don't see results here, please be patient. In this case, in a future, we will use the elastic feature of Amazon in order to create as many backend machines to be able to support all the experiments that we can launch into the backend platform. So if you have selected the job and you have run your experiment, please be patient, okay? Because we are running 4 experiments for everyone we are connected. So there are 4,000 jobs running now into the QuantumPath, okay? There is a problem here now. If you leave this window, you probably will show your experiments entering in the queue when they are going into, okay? If you don't want to wait, you can click on your profile, enable the notify events, and you will be notified through the email that your job has finished, okay? There is some problem here now. I have to be fast because I was the first to launch the experiment, so I don't have problems with that, okay? But now the platform is competing between 400 jobs in order to execute your experiments, okay? To take some kind of telemetry, and I don't want to go to my backend now. How many of you have the results? Okay, there are a lot of people, so get the response in the chat will be some crazy, okay? But I could see that a lot of people have the results. Once the people, or once the backend of QuantumPath and the processes, you will be receiving the results randomly, okay? And the platform will end its execution, okay?
Pepe, one question.
Tell me.
How we know that is a fidelity problem and not a possible answer in the bell pair, in the answer of the bell pair? Because in the bell pair we know the answer, but not for other more complicated cases. So how we know that there is a fidelity problem or is a problem of other kind?
Wow, it's an amazing question.
Yes, it's a very big
The answer probably will don't like you. We don't know. We don't know. Even we have in a paper the mathematical study of the circuit, and we really know what results we expect to receive, okay? We are at the end working with binary information, and when we create a problem, in this case, with this circuit, it's very simple to know about that, because in my circuit, I only expect to receive 2 bits at the end, okay? So if I have a Hadamard gate, my results could be 0, 0 or 1, 1. I expect to have these results because I designed my circuit to have these results. In a bigger experiment, at the end, we are working with different bits. So we need to test our algorithm. When we have an input, we will preview to have this output, and we know about that. Of course, first of all, we must design our circuit to be simple. And in a big problem, at the end, it's the same problem, but with an exponential use of qubits that makes our problem bigger and bigger and bigger. But at the end, the problem starts with a simple problem, okay? This is, I can answer in this situation, but I can put the finger in the eye. We are finishing a testing lab application of QuantumPath that will let you create some kind of neurons and testing and results, and you can compare the results in order to understand when the results give you the proper value or not through experimentation, okay? So at the end, you will know that your results are good, testing and analyzing the results. I probably give you an answer that is not the most proper answer today, but of course, when the QPU providers make really real good machines, we don't have this problem in the future, okay? More questions? There's no more question? Okay, let me 10 minutes more. We want to create a new experiment. Why not, okay? To create something more complex. Oh, let me see one question. Okay, there are no questions at this moment. Okay, okay. Let me create an experiment. We will create a CRG or custom number generator, okay? Because it's really easy to create circuits, why not? And we will create a circuit that is useful in the real life. Go again to the working on circuit catalog, okay? And then click on create circuit. I put here custom number generator, DNR, circuit. I will put here the namespace. Because I create a namespace before, I can click on the namespace button and select the key area namespace. Again, my solution, again, quantum gates, and here, custom number generator. And circuit body, I will click on edit circuit. In this case, I will create a random number. Okay, please, this is intuition at the end. If I change the states of the qubits and I never put a Hadamard gate, we are creating classical software. One circuit is quantum circuit in the moment in which we use the Hadamard gate. So if I put here, for example, this circuit and I don't drag anything and I let the 1, 0, the result of the quantum machine will be 1, 0. It's a binary value. But if I want to create a random number generator, I can drag, for example, the Hadamard gate into 4 qubits. We have now a representation of 4 qubits that can give numbers to us from 0, 0, 0, 0 to 1, 1, 1, 1. 2 to the 4 numbers in this random number generator. Okay? Are we seeing this screen now? I am creating a new circuit. Okay? Well, because I want to have a random number, I have dragged 4 Hadamard gates, and then I will measure this, and I can drag 4 times the measure. So in this case, our circuit is a random number generator circuit. If you do that with a classical circuit platform or using code, you need to compare how easily it is to create a quantum circuit for random numbers and how complex it is in the classical way. Once I have that, any problem with that? Are you seeing my screen? I see a lot of people. Okay, perfect. I have our random number generator, okay? And I will click on Save Change. I click Close, and I click on Save. In this case, I don't check the auto flow creation. I will create the flow myself. But important, I have to click on Compile. If I forget this step and I create the flow and I don't have enabled my automatizations, if you don't compile the flow, you will have errors in the transpilation option. So in order to transpile, you need to be sure that you have compiled all your assets, okay? In this case, I click on Compile. I will go back to List, and I will go to Flows. Again, I will create a flow, and I will call this flow custom number generator. Oh, namespace will be this one, test, DNR, DNG, whatever you want. And in the flow body, I will click on the Edit Circuit Flow. In this case, again, I will put, and in this case, the CNR circuit. And again, I will drag and drop because I need to run this sometimes to get some random values. Of course, you don't have to put this always. If you want to run the experiment only in one shot, you can avoid to use these saves, okay? To reduce the execution time, let me put 10 times to repeat our circuit, okay? I drag the saves, and once I have that, I will click on Save and Close. Everything now has dragged the flow and has the screen like me. Any problem with that? That is the same. We are repeating the same concepts. So I understand that this is not a problem for you. If you want to minimize the time of the experiment, you can reduce that or even avoid to use the repeat gates. Okay? Well, I click on Close. I will click on Save. And because I have the automatizations enabled, when I click on Save, these are transpiling now, okay? So if you don't are sure that you have already, you can click on the compilation results, okay, in order to see if you have problems here, and you can click on transpilation results to see if you have problem here. Because I understand that you are running a lot of experiments into the backend platform. Because we have limited 2,000 queues now, I probably have to wait to get my compile results and my transpilation results. In the rest time, I will upgrade the capability of the backend in order to execute at least 1,000 experiments, because now we are too limited in the number of threads you are launching to the backend, of course. Okay, let me then some minutes to have a rest. Let the platform finish all the experiments that all of you are launching now, because for organization, we have a limit of 2,000 of experiments. You are probably using all the slots we have to run your experiments. So probably we can go to the next of the steps until all the experiments finish. So what about if we take a rest now, okay, 10 minutes more or less. I have to ask you, please don't launch a lot of experiments to the platform, okay, in order to be able to continue to the demo, okay?
Sounds good, Pepe. Let's take a break for 5 or 10 minutes, and we will take over after that.
Okay, to all the people that don't have results now, please be patient, because all the commands are received for the platform, and the platform, in whatever take the slot, will launch your command and will give you the result you are expected, okay? So let's take 10 minutes of rest time. I will be here if someone wants to answer something out of time, and to help someone if there is a problem in the platform, okay? So then
Sounds good.
we could do the rest time. Of course, we have 10 minutes, so now we have the 5:57, 10 minutes until 10 minutes past, okay? Well, I'm seeing a lot of activity in the chat. If the compilation details is empty, is normal? Yeah. If you have launched the compilation action and the system now is launching a lot of threads in the backend, your command compilation probably will waiting to the slot to execute your command. Okay, so it's normal. It's normal. We need to enable the elastic ability of the Amazon infrastructure in order to be able to create as machines as we need to process a lot of commands for a lot of users. Okay, but this is not enabled for today, but we will enable soon, of course. Okay, 10 minutes. See you. Okay, 1 minute to start again. Wow, there are amazing questions in the chat. Marco, let me answer this question later in the event. I will think about that and I will answer you in my possibilities, or I will share with my team, of course. So once we have upgraded the limit of the organization, I understand that the people saw the system more agile, okay? So I suppose that we again can do some kind of proofs. Let me, for example, click on compile my flow, and I see if the system responds me as fast as I need. Okay. Oh my God, there are a lot of processes running now. It's amazing. Please, people, let the system breathe, please. And I need to enable the elastic part as soon as possible. Okay, 10 minutes. We need to see a lot of things we have on time, but I prefer to talk about all we have to see. Okay. So let's continue. Okay. Okay. Fast resume of all that we have saw in the presentation. Okay. We have understand how QuantumPath organize the assets into the enterprise. Okay. We know that we are creating a product that tells you how to create solutions. Okay. And we understand the solution is all the pieces that we must to put together in order to create an industry-ready or enterprise-ready solution that mix all the quantum advantages we have in our hands to put inside an hybrid architecture that could be called by a classical machine. Okay, and we have reviewed how you can access to QuantumPath. You can create solution and connect your solution with different QPUs. Then we have created 2 experiments that are the result of 2 assets. Okay, the bell pair experiment and the random number generator. We have created 2 flows. Each of these flows is our main procedures. We have launched them and we have results. Okay, if the system is really busy now, but you need to have your results again, I can click in the execution pane and I could see in my results. Okay, system is busy now. I will have my results. Let me 1 minute. Okay, go to. Okay, my results when I launch my experiments in the bell pair, you could see that even the platform is now busy. I could have my results here. So if I have to wait more results, the democratization of the quantum machines pass for this kind of things. Of course, I will don't talk about that, but in the bracket part, I have my screen here. In the bracket part, you could see the results of your experiments in the bracket dashboard. Okay, if I go, for example, to the Amazon Web Services TN1 and I go to my jobs, I probably will see here all the jobs I have launched into the platform. Sorry, the tasks. Here are the tasks I have launched to the bracket part. So this is a demonstration that at the end, all of our agnostic design and our executions at the end flows through the provider. So in the bracket part, you could have your resume of your executions and you have your data here too. Okay, and of course, in the bracket part, you can measure the cost of that kind of experiments. Well, once I have talked about that, I have demonstrated how QuantumPath has launched the experiment at the end in the provider. And for the rest experiments I have launched, I will have to wait for the results of that. Okay. If I go to my number generator, I don't have results now. So I have to understand that the system is really busy now processing your experiments. Okay. Well, I have to ask you to download the level of experimentation now in the platform to be able to explain the rest of the process. If I see that the platform is busy now, I can open my lab environment and continue with the experiments. Okay, we will see how the flows are finishing and we will try again later through my explanation. Okay, well, let me follow a little more with our agenda. We have talked about solution, assets, quantum gates, the capabilities of the quantum gates editor of QuantumPath. And now let me jump again to the other kind of solutions we can design into the QuantumPath core. Okay, we are now entering into the quantum annealing software development. This is an amazing part of the quantum technology. And there are a lot of things we can talk about that, but for time and for reduce the explanation of this kind of concepts, let me talk first of all how the quantum compositor for annealer works. Okay, at the end, when we are talking about annealing solutions, we are talking about optimizing solutions. In this kind of problems, we have a lot of variables that can interact between them and can have a lot of values. And one value of a variable can have impact to the rest of the variables we have in the problem. If we need to solve these problems with classical computers, the problem is the number of variables we can process in a limited time. Okay, if we have 5 ways to find the target we have to go, with only 5 streets to go to the end, it's easy to select the way we have to choose to go to our destination. But if we have 1,000 of possibilities, and we have a lot of variables around the streets, like the traffic and the people and the semaphores and something like that, when we put all of that together in the same box, the system will have problems trying to mix all the possible values and combinations in a moment, okay? But with the quantum machines that use the annealing technology, it's amazing to know that we have millions of qubits prepared to use a specific branch of the quantum mechanics part that are the annealing mechanism. This is a really amazing mechanism that I will don't talk about that. But the effect of this tool is that we have the possibility to define a lot of variables, interconnect them, and let the machine choose the best option we have, that for the nature is the target that consumes less energy. At the end, we are talking about a formula that has a specific composition, that is the Hamiltonian. At the end, the Hamiltonian is a formula in which you will have all the summations of the combinations that you need to have in your mind to solve a problem. In this Hamiltonian, you need to benefit the results you want, and you need to penalize the values that are not good for you. In your Hamiltonian, the mathematical composition will have some terms in which of them you benefit the system or penalize the system. The combination of these rules will go into a matrix that is called QuboMatrix. And this QuboMatrix gives all the information to the quantum machine to create the experiment and select from all the possible combinations the best one. And this is done in milliseconds. We are talking about 1,000, 1 million of variables that we can cross together to obtain a results. It's amazing. It breaks your head. Okay. The main QPU we can use for that are or simulators that are really limited in terms of classical computation, or the deep wave machines that are able to cover a great number of variables working together to find the best way. To compose the Hamiltonian, at the end, you have to have in your mind how to prepare this Hamiltonian value. For that, we need teams with polymathic knowledges, okay? You need to mix to design the dissolution, mathematical people or physician people that helps you to create the Hamiltonian. But once you have the Hamiltonian, it's really easy to use the QuantumPath tools to composite this Hamiltonian with visual representation. For that reason, we have the Quantum Compositor for Annealing tool that provides to you a single use of tools in which you can define your variables, your values, your variables in terms of I want to store some kind of value, and then define the rules. And the rules are all the mathematical terms that you can combine that composite the Hamiltonian, okay? In this case, we are talking about a tool that lets you the possibility to create visually the Hamiltonian that will be mapped to a QuboMatrix using agnostics tools. So you define your formula once, and you can run this formula whatever you want in different annealing technologies. Of course, you are visually designing the mathematical problem, so you will see in the language of the mathematical problem what kind of problem you need to solve. You are not seeing code, you are seeing the mathematical formula. So visually, you can design the problem with the same tools that the mathematicals or the physician people need to solve the problem. Of course, our tools helps you to define all the stuff with rules, syntax, color, help when you made a mistake. All the stuff around this visual environment is provided by the Quantum Compositor for Annealing tool. Okay? So let's go to a sample now. Try to think that we want to create a simple optimization problem. Well, We are here with the amazing Amazon team. So what better that talks about how to distribute some kind of packages following some kind of rules. In this case, what will be the problem? We need to send a messenger with a bag and put in the bag the best combination of packages to distribute some kind of products. In this case, the problem is the next. We have different packages, and each package has a cost and is capable of store a weight. The problem is that we need to ensure that for a specific amount of price, we need to optimize the weight of the boxes we can we can put in our bag and send to the destination. Okay. In this case, the rules are the next. We need to send 6 kilograms of products, and we need to maximize the costs of the products we want to send. So if you see the values of these boxes, try to find in your mind a possible answer for that. So we see that we have a box with 1 kilogram and cost €4, a box that costs €1 and supports 2 kilograms, and all the boxes we have here have different combinations with different weights and different prices. Okay, if our target formula need to maximize the 6 kilogram objective to send the packages, maximizing the price, the composition of the Hamiltonian follow these rules. First of all, we need to select the variable, and the variable is, hey, we have the item in the box, 0 if it's not possible. So we have to choose the box. Then we need to maximize the price. So for every box we have, we need to sum the maximum price of the boxes we need to combine. Okay? And the rule that we need to obtain is the summatory of the products we have selected don't be different than 6 kilograms. The composition of the Hamiltonian follows some kind of rules, but at the end follows this formula. And this, inside the system, is translated into a Cubo matrix. Of course, we need to create the problem that creates this Hamiltonian and see if the results give us the best combination of boxes for the prices we have defined in some kind of variables. Okay? So to do that, because the Hamiltonian process is tedious, because we have to define some terms, the quadratic terms and something like that, let me share with you through the chat code of this experiment. Okay? And we will create a circuit, copy the code I will put you in the chat, and we will review the characteristics of the quantum Hamiltonian editor. Okay? So let me copy this JSON code in the chat. So let me see if I can copy all of that in the chat or not. So let me 1 minute, because I think that the system will not let me go to copy all the code. Oh my God, the chat is really limited for that. So other way to put this information for you as soon as possible. Yeah, I can copy all of that in the chat. No, can copy. Okay, well, let me execute experiment by myself, because I can't copy all the JSON text into the chat window. Okay, this is the limitations of WebEx in this case. And when I run this experiment, we will send this experiment for you, and you will try this experiment in your time, because we will let open the platform for 2-3 days, as Juan mentioned yesterday. Okay, So I'm sorry because I can't copy here now, and we have other ways to put this file to your hands, but this consumes time, and we are running really fast. Okay, to run this experiment, let me remind you that we have the solution demo for annealing that is connected to a quantum simulator and a D-Wave QPU in the Braket part. Then I will go to the circuit part, and I will create a circuit. In this case, I will call this circuit box optimization. I will put in the namespace my name J area, but I can call, for example, anneal in order to separate in the namespace the tags of my objects. Okay. The solution in this case will be selected as the solution demo for annealing, and the technology we will use will be the quantum annealing technology. Okay. In this case, I'm talking to QuantumPath that I want to design an annealing circuit, and I need to use the solution that supports our QPUs that works with annealing. Okay. In terms of description, I will click on blah, 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 and in the circuit body, I will paste JSON representation of our meta language for the Hamiltonian. When I click here on edit, we will see that the visual compositor is now lowering this information. For example, if I go to auxiliary data, I could see that we have defined two sets of values. The first value is the prices, that in our case, we have 5 boxes. The prices are 4, 1, 2, 3, 5. I have other auxiliary data called weights, in which I put the different weights for every box. The box 0 has €4 and 1 kilogram, and so on. So we have defined 2 arrays of different values composition for each box. Then I go to the classes option, and here we define the visual representation of the variable. In the system, for us, this is the class, and the class defines a name, and this name will give you in the results the name of the variable that you are searching for. Boxes from 0, boxes from 1, boxes from 2, and so on. In the variable section, we create the IT representation of these classes. In this section, we have created the boxes. With this information, the system could validate your information in order to analyze the Hamiltonian and see that everything is working okay. At the end, we have the rules. And in the rules, we can create new rules as we want, okay? And we can add different kinds of expressions to compose the Hamiltonian. But at the end, we have 2 rules. One rule that maximizes the package price, and one rule to obtain that the total weight must be 6 kilograms, and no more and no less. If I select, for example, the maximized package price and I click on edit, I will see the visual representation of the Hamiltonian. And in this case, with the visual environment, I can edit this formula and change whatever element I want, and with the right button, I can change or add or click or put new expressions. So for us, this process is visual, totally visual. Of course, we can interact with the lambda values. These lambda values let us the same that in Spain are done with the, I don't know, how do you call in the montaña rusa? Oh my God, what is the English term? Well, the lambda is a value that gives us the possibility to maximize or reduce the value in terms of what we want to prioritize in terms of the Hamiltonian. What is more important for me, the weight or the price? With the lambda, we can stabilize the priority of what terms of the Hamiltonian is more important for me. Okay, so once we have defined the Hamiltonian and we have all the variables that mathematical people or physician people has given to me, then we have the visual representation of the Hamiltonian. So with our graphical tools, we could see with the people that define the algorithm what are the mathematical expressions we need to translate in terms of QuBO codes. So it's really easy to compose the formulas if you have your formulas in your mind, of course. If you don't have experience creating Hamiltonians, for you will be a pain the first steps in the platform. But if you have experience with that, or you have people that can help you to define the problem, it's really easy to be manage this kind of problems.
Sorry, Pepe. Sorry. Could you repeat, please, all the steps?
Yeah, let me create in one moment the flow, because we are running really just on time to talk about qSOA. So let me repeat again. I will save and I click back. Okay. Well, when you want to create a circuit that use annealing technology, you can create on you can click on create circuit, and in the metadata we need to put some metadata as we saw before with the previous circuit of quantum gates. But now we need to select the solution in which we have the QPUs that are able to execute annealing problems. The second important step is to define the quantum type. In this case, in the combo box, we need to select the quantum annealing technology. Doing that, you are telling to QuantumPath that you need to enable in the edit circuit the quantum compositor for annealing editor. Once you want to define that, you probably work with a lot of combinations of the tools we have in this environment, okay? But at the end, all this is resumed in some kind of input in which you put the values you want to optimize, the variables and its values. In this case, we have defined two arrays that are the inputs of the system, and we have created a class that will get the arrays with the values we want to maximize, okay? Then we define the variables that are the IT representation of the class. These give us the possibility to, in the results, codify the result mapped to the class that has the correct value. So this is a very important part for us, okay? And then the last step is define the rules. The rules are the different mathematical terms that compose the Hamiltonian formula. In this case, we define every rule for the different combinations of the information we want to optimize. In this case, we have defined the optimal price of the box, and in the other rule, we have defined the weight rule that limits that the all weights of the boxes need 2 through 6. Okay, this responds to the define of the Hamiltonian term. I know that we need to talk about that more, but it's really interesting because at the end are summatories that tells to the system what kind of information we need to benefit to obtain the best energy and what information we need to minimize to create some kind of exception in the system. Okay, we are talking about energy levels, and this is the composition of the Hamiltonian. Once we have this defined and we have cleared the Hamiltonian, we can click on save, like the circuits we have created before in QuantumPath. Once we have that, if I click on save, the system is the circuit is saved, and the algorithm has been transpiled to our intermediate language. Okay, I could see that the system is now heavy again, so I couldn't see the results of the compilation. So please, I have to ask you to finish your experiments, because if you don't let me enough power to do the experiments, we probably lost time. So let me 1 minute, please. Let me 1 minute. We always have other way to test that. Okay. So in this case, we have the boxes here. Okay, and let me copy my code. Oh my God. Here, I will paste it. I will edit to show that everything is okay. Perfect. I click on save. The system is saving and compiling. Okay, once I have that, in compilation details, I can see the intermediate language. is a really simple language in which you can define the rules easily using our intermediate language. But of course, we have visual tools for that. We have created the boxes circuit, and I need to create the flow to execute that. In this case, if I create the flow, for me, the flow is the same flow that we can create using the gates editor. At the end, the flow representation is the same in every case. We design different kinds of circuits in QuantumPath. So in this case, I have created a flow chart to execute our circuit that is called box test. Okay. In this case, we don't need to put some iterations because in this case, the quantum machine will execute the QO matrix as many times as it needs in order to get the most efficient value to combine the boxes. So I don't need to put the iteration back. I click on save. This automatically saves the editor, create the compilation, and we will receive the transpilation results in a few seconds. Okay. So let me see if this has finished today. Transpilation boxes. Okay, let me 1 minute. I click on transpile. Here it is. I have the transpilation results and I have the value now. Okay, I'm ready to launch my box. Because I have a lot of items in this organization, I can click here box to find my flow. In this case, if I click on the dashboard, I could see here my different QPUs and simulators as we saw before with the gates editor. To run this fast, let me click on the Amazon Braket Lockat exit solver. And for example, well, let me click the Amazon Braket. I need to set up the solution before and we are running out of time. Let me click on run flow. I am executing now this optimization problem. And with this problem finished, I will probably get the results. This is the experiment here. And I click on the histogram part. And you could see that our class has the name boxes in the solution. So it's really easy to get the histogram and study the values. These machines are telling me that the best result of combination is mixing the box 1, 2, and 3 and not use the box 4 and 5. This is tremendous curious because if I go to the presentation and I see what boxes have we to present the results, the first intuition we have is, for example, to use the box 4 and the box 2. At the end, these two boxes sums 6 kilograms, but if you compare the prices, it's less than if we use the box 1, 2, and 3. Oh my God. If I see the problem in my mind, I see the first combination and it's really fast to use. But the system has told me that if you use the boxes 1, 2, and 3, you sum 6 kilograms, but you gain €4 more than your first combination. So it's amazing. System works. What is amazing here? If we have 1,000 boxes, is for nothing trivial to find the results. So in a quantum machine, we can mix 1,000 boxes together, launch the experiment, and in few milliseconds get the optimal results, just like a click. Try to imagine these applications in logistics or medical or searching for a road in your map. It's amazing. You can process a lot of information together and get the results instantly. And of course, in this case, better than me, because I choose a combination of boxes that was not the best option. It's one option, but not the best. So it's amazing to see how the annealing system works and the possibility we have to play with that, simply creating the Hamiltonian formula. You have seen that in our platform. Okay, so let me go to the rest of the parts we have to see, and I will let to the people in the question and answer because This part is tremendously easy to explain, and we have a lot of tools around that. So, closing the circle, we have talked about how to use the quantum assets to prepare experiments, circuits, play with gates, play with annealing, but at the end, all of that has a purpose. The purpose is that we have a flow that is able to run some kind of quantum program that expects an input and gives an output. At the end, what can we do for that? With that? Well, in this part is in which we start to talk about qSOA. qSOA is a technology we have in QuantumPath that gave us the possibility to create simple use cases in terms of REST API that give the possibility to the classical applications to call the quantum part, but with no need to know that this is a quantum part. At the end, the marvelous of this technology is that with qSOA, you only need to use the REST API and tell QuantumPath, hey, please connect to the system, run the experiment boxes, and give me the results. In the classical part, the REST API is a really known a protocol to launch remote experimentation, and we use a really high-level protocol to connect with the platform and establish a dialogue, okay? So in the platform, we solve these kind of problems. As you can see in the presentation, in a classical perspective of how to define the quantum parts and with the vision of the providers, you need to create a piece of use case with different technologies. If you use, for example, the Qiskit 1 or the Amazon Braket, you need to define the code for every platform. Okay, with Braket is more simple because you only need to change the QPU. But you need to keep in mind that you have different QPUs, different combination of gates. You need to select that, change the version. So if you have different providers in your teams, you need to factorize your code as many times as different providers you have, okay? But in QuantumPath, because we are agnostic and the platform do the rest for me, in our context, we are proposing that solution. You have your classic IT with all your programs in the backend. You have the client consuming all the requests to the classic part. And in the moment that the classic part needs to run some kind of quantum experiment, you only need to run into our qSOA API and QuantumPath do the rest for you. You can access to the platform at every level we show in the visual environment. With our qSOA REST API, you can connect, launch, get results, or you can connect, create a circuit dynamically, compile, execute, and get the results. So this is amazing in terms of an enterprise architecture that keeps clear the way you can use to create quality software. Okay? We have clear and standardized connection points. We are manufacturer agnostic. So in terms of classical part, you don't want about what kind of QPU are you using into the backend. And we democratize the access because we have the possibility to access to the system and request some past results or launch the experiment if we need real-time information. So it's really simple to use trusted technology. So in the process we have defined, the company have a problem, the team generate the products, you publish the flow you have finished to put in production, and the classical part only need to go to the use cases to have the results they are searching for. No need about technology, connection strings, and details about the specific technology. Our REST API is the same that we are using in the Windows. So this proves and it works. And you only need to use some kind of high-level instructions in order to interact with the platform. We will see now that part. We first authenticate with the platform. We can tell the system, hey, give me my solutions, For that solution, give me the flows I need to choose, and please run this solution for me and get the results with high-level functions. Okay? At the same time, you can call to the system and create assets, update assets, compile them, and then use the qSOA API to execute them. So you can create classical parts that define dynamically circuits in the system, execute them, and get the results. At the end, when we have machines with more than 100 qubits, we will need systems to create circuits. It's a reality. In the moment that Braket, for example, gives us a machine with 1,000 qubits, we cannot create circuits without the help of the machine. So this part of qSOA gives you the possibility to create unlimited qubit circuits, okay? Only using a simple REST API. Of course, the qSOA opens you the doors to create verticals, solutions to different areas of the enterprise or industry requirements, okay? So for that, qSOA at the end is the connection between the quantum technology and the classical technology. So to finish, let me run some kind of tests. Sorry, because I want to follow the schedule and we are running with a small amount of time. I hope that we will see in more events later on. Okay, so let me show you how this works. In terms of the platform, I have here the qSOA link, and behind the SN, we have a URL that is your connection point. In this page, you could see some kind of documentation of all the API REST we have to connect to QuantumPath. You can create your own clients using your preferred language, okay? But we have in our platform, and we can distribute it for free, the C# SDK, the Python SDK, and the Java SDK that is in working now, okay? How can we demonstrate that this works? First of all, it's important to understand one thing. When you need to publish a use case to the outside, you need to go to the flow, and in the metadata, you need to enable the publish option. If you don't do that, you probably won't see any use case through the qSOA API. So you, as proprietor of the asset, need to decide that you want to publish this flow into production. So inside the flow, I can enable the publish option and save that. And I can do the same for all my flows. I go to the CNG flow, click on publish, and do the same with the annealing box option. I go inside, click on publish, save, and back to list. Okay? When I have that, I have now the possibility to create a Python notebook or a C# application and test that this can be integrated into a classical platform. So for that, let me show you our Jupyter notebook. We have the SDK with a file that we can deploy to you easily in the platform with the links you will see in the next days, okay? And in this document, we have all the SDK of the QREST API perfectly documented. For example, if I run that, you can install from the notebook the SDK, and we have different versions for that. Of course, because I have that previously installed, this gives me all the warnings of the notebook. Well, if I go here to the quick start, the first of all I need to understand is that we need to import our notebook SDK and use all the functionality. First of all, which environment I am using now? If I click play, I am connecting to the platform, and we have two environments defined, our lab environment and our pro environment. So in this case, I will click on the lab, to ensure that I have all the tools to execute my experiments, okay? And now the system is telling me that I will use the lab experiment, okay? If I click, for example, in the echo ping, I am telling the system, hey man, is the security service enabled? Yes. Please authenticate me. If I put my username and my SHA256 codified password and I click on run, I'm now connecting with the lab environment, and if we works perfect, I will see that I am authenticated now. To be sure, I can click here to run authenticate X, and it validates that I can authenticate it, okay? If I run the echo status, so let me authenticate again. I have a problem with that. Yeah, I click here in the authenticate, active session 2, and for example, what is my user? Okay, the admin. What is the version of QuantumPath? Hey man, you are in the development context or lab deployment. Okay, what are my solutions? And here comes the JSON results from our qSOA API. Hey man, if I want to get the solution name of a specific environment, I can click here and I can play with the API. So let me run an experiment using the API. I go, for example, to get quantum device list. If I click here, I have all my solution QPUs. If I choose a solution and map to the execution flow list, for example, hey, how many experiments I have in this solution? And then when I have already read, I load the application name, I select the solution, I select the flow, and I select the QPU. All this information is get with the API. If I click here and run, I have launched an experiment and I have a token of the running experiment. If I click here and I play the get results, okay, here with the quantum response, I click here, I get the results, and really interesting, we have visual representation of that. So it's the same that you saw yesterday with Juan in the Braket part. With our REST API based on Python, you can do the call to the system, but without codifying the circuit. You only need to connect to the platform, tell the system which codes do you want to run in terms of solution, flow, and QPU, and get the results. And it's as simple as launch 5 instructions using our QPU. Of course, the backend team that define the circuits could be continuous working on that, publish the results, and without change this visual environment, you can run the experiment and get the updated results without taking everything in the system. It's amazing. This is our qSOA REST API.
Okay, Pepe, we have to finish in.
Okay, sorry, I want to show you how works the C# form, but in another moment. So for me, this is enough today. Let have the people like question answer now. Is a question of all the things we have saw. I'm sorry to go so fast in the last step, but the target is to show what QuantumPath can do for you. So any question?
Share the slides, please.
Tell me, Mario?
Share the slides. The slides.
Okay, it's really important that you please fill in the survey you have in this link now. I put the link in the chat now. So let me 1 minute to put the link. Oh my God. I will copy the link to put in the chat. Please fill in the survey, and of course you have my email, and please, the survey is really important for us because we can make the things better if we answer the survey. And if you fill in the survey, all the material that are the presentations, the questions you have made, the experimentation of a annealing part, all the documentation we have generated for this event will be sent to you. Okay, is the the okay, the reward if you fill the survey. Okay.
Okay.
Of course, if there are no questions, give me 1 minute more to thank to all the people that have made the event possible. Of course, the Amazon team, amazing people to work with. Okay, and all the team, the people that make the team we work, and I have the pleasure to work that. Okay, and of course to all of you, thank you very much for your time and for your patience. And I think that you have the possibility to learn this so fast. And please use the platform and give us feedback. So, any question? Thank you very much to everyone. If there are no more questions to cover, we have burned all the time of the event. So thank you very much. If you need more information about licenses or whatever, you have the Quantum website, okay? And you will get more information about different kind of licenses we have for research and for experiment and something like that. So that's all. There are no questions. Amazing. Okay, please. You have our email in the presentations. So whatever we can do for you, please don't doubt to contact us. Okay. So thank you very much.